Hi, today we look at one of the applications of definite integral. The question says find the area of the finite region bounded by the curve y equals x squared minus 5x plus 4, the x-axis and the ordinates at x equals 3 and x equals 5. Most of the time when students see a question that involves area enclosed by a curve and some ordinates, they just dive into the integral of the function given and taking the limits of the integral as the ordinates given directly. But this is usually erroneous, as most of the time that is not what gives the area. So the best practice is always to first sketch the curve and then see exactly what is happening. The curve being a quadratic, we can start by completing the square in order to have the coordinates of the turning point. So we have x squared minus 5x plus 4 equals x minus 5 over 2, half the coefficient of x, all squared minus the square of that half the coefficient of x, which gives 25 over 4, then plus the constant term. Finally we get x minus 5 over 2 all squared minus 9 over 4. Hence, from completing the square, we can see that the line of symmetry is x minus 5 over 2 equals 0, which gives the x coordinate of the minimum turning point as 5 over 2, while the y coordinate of the turning point is negative 9 over 4. We also need to have the intercepts, especially the intercepts on the x-axis, which are 4, 0 and 1, 0. The intercept on the y-axis being 0, 4, and then we can have a rough sketch of the quadratic curve, which shows clearly that between the ordinates at x equals 3 and at x equals 5 there is a root of the quadratic curve, and so one region of the area we are supposed to calculate is below the x-axis while the other region is above the x-axis. So you can now see why it is important for us to sketch the curve in order to see exactly where the area lies. For the region below the x-axis, we would get the area by taking the integral of the quadratic function with respect to x from x equals 3 to x equals 4, and that integral will be negative because the region lies below the x-axis. Hence we have to take its absolute value in order to get the area in that region. Then the area between the ordinate at x equals 4 and at x equals 5 is above the x-axis, and so the integral from 4 to 5 of the quadratic function with respect to x would be a positive value. The required area will then be the area of the region below the x-axis plus the area of the region above the x-axis. As I've already said, we need to take the absolute value of the integral from 3 to 4 of the quadratic function, because that integral will be negative due to the fact that the area lies below the x-axis. And so proceeding to integrate the quadratic function x squared minus 5x plus 4 with respect to x, we have x cubed over 3 for the integral of x squared minus 5x squared over 2 for the integral of 5x plus 4x for the integral of 4 with respect to x. And we have to substitute the limits from 3 to 4 and then take the absolute value to get the area in that region, plus the same integral again, this time the limits from 4 to 5, which represents the area of the region above the x-axis. From there we proceed with the substitution of the limits. The upper limit 4 substituted minus the lower limit 3 substituted, and we are taking the absolute value of the result, plus the substitution of the limit in the last integral, substitution of 5 minus substitution of 4, and upon simplification we get the absolute value of negative 8 over 3 minus negative 3 over 2 plus negative 5 over 6 minus negative 8 over 6, which gives the absolute value of negative 7 over 6 plus 11 over 6. Absolute value of negative 7 over 6 is 7 over 6, and 7 over 6 plus 11 over 6 will give 18 over 6, which gives 3 square units as the required area.